No. Give us a second here. Zoom, PowerPoint. Complexities as usual. I think go on the right, maybe. Let's see. Maybe. That is not sharing anything. No, still no luck. No. You want to stop sharing and then restart it? Restart sharing, see if that's because I think you've just been changing the sharing. It's still stuck on you sharing, right? That's what I'm gonna get to. Oh. You seem to have fallen off Slack. Oh, Zoom Slack, sorry. Oh, there he is down there. Okay. There we go.
There it is.
Please ignore our first few minutes.
And you guys can hear me okay? Guys on the Zoom, can you hear me okay? If one of you could mute and
I can hear you okay.
You can?
Yes.
Perfect. Yeah, thank you. All right, thanks, Kyle. Thank you for the opportunity, everyone. Kyle, we have 45 minutes, right?
Yep.
Okay, perfect. Awesome. Hey, it's great to meet everyone. My name is Kiran Kamity. I'm the founder and CEO of DeepFactor. We're a next generation application security company that takes an integrated approach to combining SCA, SBOM, runtime security, and runtime analysis into an integrated solution. And one of the really unique things that we do is this technology called runtime SCA, which essentially correlates which vulnerable SCA components actually got loaded into memory, and therefore tries to prioritize the high risk items for you. So this presentation today is based on some of the work that we've done over the last 4 years, but I'm not, as much as I'm a DeepFactor representative, I'm here as a representative of the AppSec community, trying to push the boundaries of what's possible with today's application security today, and that's what this talk is going to be about. It's actually it's not a vendor talk. It's a concept. It's about how we can truly push the boundaries of what's possible with AppSec today by combining static application artifact scanning with runtime analysis of applications. I will be using the DeepFactor product from a demonstration standpoint just to highlight what it can, what we can get out of this correlation. Obviously, because that's the product that I'm familiar with and we've built. So, all right, cool. So those disclaimers out of the way, let's jump into the fun parts. This is the agenda for the conversation. I think the slides aren't refreshing. There it is. Yeah, it's just a delay. So this is what we're going to talk about today. The first generation of application security tooling, what limitations we have at that, especially around software composition analysis. What does this, why is there a need for next generation of application security tooling, especially something, we view SCA 2.0, which is the next gen of SCA, as an SCA that is enriched with runtime because of the prioritization benefits that it gives you based on what actually is meaningful to your enterprise from a risk perspective. We'll then do a technical deep dive and a demonstration of the product to walk through how you can visualize some of the benefits of combining and marrying runtime analysis with SCA. And when I say SCA, I'm talking both about dependency scans and container scans. So I'm going to use that kind of interchangeably. And if you are analyzing runtime anyway, then in addition to runtime correlation with SCA results, what other things can you do with runtime? And that's something that we're going to talk about as well, because true runtime security spans beyond just runtime SCA. So we're going to talk about all of those today. Boy, there's a massive delay in refreshing this. Yeah, I think there's too much delay. Yeah. Let me see if I can go through. I think the internet connection here is going to work for the slides, but it will not work for the demo. Does anybody else have a better internet or a hotspot that I can piggyback off of? That's really not a good question to be asking a security person, but yeah. Okay, let's see if this works. Let's go with this one for now, because I have a demo as well. Maybe, yeah, exactly. Okay, cool. How many of you guys have issues with too many alerts coming in from your dependency scanners or container scans? Okay, great. So all the AppSec people in the room raising their hands. What is the problem with it? Why is it a problem if you have too many alerts? I think it's kind of a rhetorical question, but I think it's a good idea to. Sorry? Exactly. So the audience member here is saying if everything is an emergency, then nothing's an emergency. Basically, by telling our dev teams that there are too many risks in their applications, we're not giving them an accurate identification or prioritization based on what actually matters to the business. Therefore, we end up as security people giving too many things to our dev teams for them to go attend to in a short period of time. And developers have other jobs. They have the job of building their code for the application they're trying to create. And the faster they can get done with the security stuff, the better it is. So if we as an AppSec team, can prioritize and say, hey, look, these are the 1,000 things that are vulnerable, but I think these 50 are the accurate, represent the highest risk for the enterprise. So dev team, please go fix them first. You don't have to ruin your Thanksgiving weekend to fix every instance of the OpenSSL vulnerability that was ever found, as would happen in last Thanksgiving. But fix the things that matter, that actually represent the highest risk, and then go take your Thanksgiving break and come back and fix the rest. That is a much more mature way for us all to do AppSec. And I think it's going to go over really well with dev teams as well. So that's what makes this next generation of application security interesting. Because AppSec 2.0 is not just scanning artifacts. I think we as an industry have gotten pretty good at scanning our artifacts. We have so many scanners now, you can drop them into the CI pipeline and scan your dependencies, scan containers, generate bill of materials, so on and so forth. That's almost become commodity. But you've got to do that because that's the first step. But where we need to go from here is we then need to correlate what's happening on the left by adding connectors on the right. When your application is running in dev, test, or production environments, if we can observe the application processes to understand how your app is behaving at runtime, and then correlating between the left and the right to tell you which vulnerable components actually got loaded into memory and are therefore reachable, that makes for a much stronger AppSec posture. So instead of saying, here's a scanner, we found 1,000 things, what we're now saying is, we scanned your artifacts, we found 1,000 things. We observed your running applications, and runtime analysis showed 50 other things that are interesting that you need to go take a look at because SAST or SCA couldn't find it. These are bad behaviors that are happening in your application. Like, for example, your developer brought in some third-party piece of code that's making an outbound call to North Korea, or it's touching etc password, or it's launching a shell, or things like that. Bad behaviors that could happen at runtime that will or likely be missed by SCA or SAST tools. And then the top box, which is the correlation, is the really interesting part to truly understand what's risk, the risks from the SCA findings. So the top part basically is saying, yes, you have 8,000 things that are vulnerable that the static SCA scanners found, but 50 of them represent the highest risk because we know for a fact they actually got loaded into memory and used by the application. And of course, everything has to be integrated with the right tooling. So the next generation of application security, AppSec 2.0, has to, of course, integrate with your Slack and your Jira and your CI pipelines and your SIMs and other things, your ASPM tools if you have any, et cetera, et cetera. So this is where we as an industry need to go. And as AppSec professionals, as you're formulating your AppSec strategy, I think gone are the days when we just think of the box on the left, and probably the left and the bottom are the two things that we think about most today. But I think if we start thinking about the right and the top, that would complete our story with AppSec. So let's focus specifically on the top box, the prioritization and correlation between static and runtime. That's what makes the next gen of SCA. So SCA 2.0 is essentially runtime SCA. So how do you think about prioritization based on risk? What represents, when you look at the hundreds of findings or the thousands of findings, depending on how many artifacts you may have in your organization, that come out of SCA and container scans, how do you figure out which ones are actually representing higher risk? And how do you filter them? How do you go from 1,000 to 50? We've created a white paper on this, and it's a pretty awesome read. And I'll share with you the QR code at the end of this, so you can read the white paper as well. But we've essentially identified it down to 6 parameters. One is reachability. Is the component that is actually vulnerable reachable by your application? And this represents, and that's both for dependencies that are part of your application, as well as packages that are installed in your container images for those of you that have cloud native workloads. The second one is usage. Yes, it's theoretically reachable, is limiting, but what really makes sense is it reachable and is it actually being used by your application? Because then you get to weed out dead code that is sitting in your application. Because if you simply say reachable, then you're basically looking at the theoretical aspect of what's reachable, but you don't know whether that was actually used by your application or not. And if you can combine that with usage, it makes for a much more powerful way of doing reachability/usage analysis. I also have a slide later on where I talk about, for those of you that are familiar with call graph-based reachability approaches versus runtime-based reachability/usage approaches, the runtime approach is far more superior than call graph-based approaches for various reasons. I'll share with you that slide and we'll walk into the details as well, because we compared both of those from numerous perspectives. The third one is applicability. You may have a Java application and your developers may be using JDK 8.x instead of 7.x, but the CD might only be applicable to 7.x. Filtering that out will also reduce some noise for you. The fourth vector is exploitability. Is there an exploit available? There's databases for exploits like ExploitDB, for example, that one could consult. A bunch of all of these next-gen SCA tools, including DFactor, right? We all bundle that information as part of the product itself, so it's presented nicely in an integrated manner. The exploit available essentially suggests to you that any person that has access to, for example, a Metasploit kind of script, like a script kiddie, can take advantage, for example, of a vulnerability that you may have, and therefore you need to take that a bit more seriously, because the chances of that vulnerability getting exploited are much higher than something that doesn't have an exploit available. And even there, I think there's a couple layers. Availability of exploit is one thing, and there's an active POC of that exploit, or there's an active exploit that has happened. Those are additional details that can help go even further down. The other one is topology. Do you have an internet accessible component? If you do, then I think you've got to prioritize the vulnerabilities on that higher than components that are internal only, for example, that may not be exposed to the internet. And lastly, of course, severity. But this is honestly the only thing we use today for the most part. And severity, again, has two flavors: CVSS scores and vendor-assigned severity. Sometimes the vendors don't go by CVSS score alone. They take other parameters into account to result in a vendor-assigned severity. So when you're prioritizing it, make sure that you're taking a look at both CVSS scores and vendor-assigned severity. So ideally, based on all of these factors, if we can show our developers or to our own security teams a Venn diagram of sorts where we say, here's the intersection between used/reachable and vulnerable and exploit available, etc., then you will be able to pick and choose which ones are the highest risks to your organization and which ones represent the second layer of risk, and so on and so forth. And then you can have an intelligent conversation with the dev team saying, hey, why is it, you don't have to work on the 1,000 things, work on the highest risk items first, and then you can work your way down from there. So the holy grail would be if we can get from here, which is what we have today, total, vulnerable, and severe. This is what we have today with our SCA tools. If we can go from there to what is actually used, then we can reduce the volume of noise quite a bit. There's actually two interesting things, or actually three interesting things that can come out of this inverted triangle, right? One is, hey, why do you have, one is obviously prioritization, right? Which is these 11 represent the highest risk, go fix it, like no questions, right? The second one is deprioritization. Why do you have a bunch of components that are vulnerable that never got used in the application at all? We can have an intelligent conversation with the dev teams and say, hey, maybe we should consider removing some of those artifacts from the container images. So maybe we should consider removing those dependencies from the application because we ran the app for a full week in dev, test, prod. We ran it for 2 weeks or 1 month in prod. And we noticed that a bunch of these components never got called. They never even got loaded into memory. So why are they sitting in our application? Is it time for us to do cleanup? Because the best way to reduce your CVE debt is to remove things that you don't need, right? That's the fastest way to reduce your CVE debt. Now, there's actually a third advantage of taking our applications and being able to picture our applications with this inverted triangle way is our preparedness when it comes to the new zero-day vulnerabilities. Zero-day vulnerabilities are not going to stop. So we had Log4j, we had Spring4Shell, we had OpenSSL, all of that. We're going to keep having more. So, but if we can, as an AppSec team, become a bit more mature when the next zero-day vulnerability comes about, this information can actually help us get there. Then I think we can have this conversation with our dev team saying, hey, you don't have to fix everything today and ruin your Christmas and Thanksgiving. For some reason, there's this uncanny coincidence between holiday weeks and when these vulnerabilities seem to show up. Yeah. Possibly, right. So now you can say, look, it happened during the Christmas week or Thanksgiving week, etc. But don't worry, you don't have to fix every instance of, OpenSSL, the example from last Thanksgiving. Today, fix the 10 things that matter. Go take your Thanksgiving break. Come back and fix the remaining 90 things. I think that makes for a much more, AppSec community.
Quick question.
Yes.
In the real world, what percentage of severe issues are not being used? In other words, how, do you have numbers on how much of the code that is causing us problems is really not being used?
That's a great question. For those of you in the Zoom call that missed the first part of the question, it was about, in the real world, what percentage are we seeing out there based on our experience? So when we work with organizations of various sizes, and every organization and every application is different. There are teams that are just get in the habit of just taking a base container image from Docker Hub, et cetera, and start using it. A little less organized, and there are teams that are a lot more organized. They have a highly locked down kind of base image. So the percentage varies. But on an average, what we're seeing is for container scans, about 75-ish% of components that we're seeing on the containers never gets called or loaded into memory, so that it presents opportunities for slimming down your images. For dependencies, it's really subjective, because if your app is really new, then it has a small amount of code, so there isn't that much junk in the app just yet. But as your application matures over time, you have a lot more people in your team and your organization gets bigger. If your app is 2 years or older, chances are you have a bunch of junk that is no longer being used, because those code paths aren't being traversed on a daily basis.
So the number you said is 75%.
Yeah, approximately. I mean, yeah. Cool. Now, for those of you that have been following some of the new ways, so new gen of SCA companies have acknowledged that it's important to prioritize risk based on some metric, and reachability has emerged as a sort of a buzzword / hot topic these days. But I just wanted to spend a little bit of time to talk about, when you are looking at reachability, there are a couple of different ways to arrive at reachability / usage / some of the other 6 things that I mentioned in the other Venn diagram slide before. There are 2 different technical approaches to doing reachability / usage specifically. One is runtime analysis, and the other one is call graph analysis that is based on analyzing the source code and the call graphs in the source code. So our CTO and team spent a bunch of time trying to analyze. In fact, we evaluated both of these approaches and then picked runtime as the right approach, as the winner here for various reasons. So I just wanted to spend a little bit of time trying to go into the details there. If your goal is to detect, so let's spend a minute to understand how both of these technologies work. Runtime analysis observes your running processes. So if your process touches a file, loads a module, loads a class, runtime analysis tracks that is happening. And runtime tools can run in your dev environment, test environment, even production environment, wherever you turn it on. Call graph analysis work by scanning your source code. So you give them access to your GitHub repos, for example, and it scans your source code. Call graph analysis scans your code, not your dependencies code. Some of them, because you could incorporate dependency into your code, obviously. That's 80% of our code is dependencies. And those dependencies could have more dependencies. So there's a fundamental limitation with the call graph approach, because either one would have had to go to the entire internet, the community of open source software out there, scan all of the open source software out there and index it per, based on each version of it. That process is quite error prone, which is one of the fundamental limitations of call graph. So if you go from top to bottom, the first one is, if the goal is to get reachable modules in your dependencies, then both of the approaches work, as long as they're not transitive dependencies. If it's a transitive dependency, then the call graph approach fails or is highly error prone, because you have to scan the universe of open source software that is out there to understand what all has been called from that piece of software. The second thing is, if your goal is to observe OS packages that are sitting in your container images, not the code that you've written, then by scanning your source code, you will not get that information, because so that second bullet is not even possible with call graph analysis. The third one is, yes, you can get, whether it's technically reachable or not, that too just for dependencies, but it doesn't really matter if your application has a bunch of dead code and it's never used. So tracking actual usage of dependencies as well as actual usage of modules in your container images is only possible when you run your application. So runtime analysis kind of beats call graph analysis there. The fourth approach is dynamically loaded modules. Sometimes, like if you application, there's a Node.js developers in here. Node.js has this concept of reflections where the modules get dynamically loaded at runtime. So by scanning your source code, it won't even be there. So you won't even know them. And so for that, again, observing your application when it's actually running at runtime gives you a more accurate interpretation. Dead code we talked about. The other one is accuracy and reliability of insights when it comes to transitive dependencies. If it's runtime, if your dependency loads another dependency, it is still running, so we will track it. If it's call graph, you do not have the code for the dependencies that have been incorporated into your code. So having an effective call graph for your subdependencies and their subdependencies, you have to essentially scan the entire universe of open source software out there and index it, right? And all of that's highly error prone. And so as AppSec professionals, how confidently can you, put your job on this and say, I know for a fact that this is not reachable, so don't use it, is hard to do with call graph approaches. The other one is, with call graphs, you're just looking at the call, but with runtime, you're actually looking at the arguments that have been passed at runtime to that function. And language specificness is also another highly limiting thing with call graphs, because you have to understand the nuance of the code that is written for every language. And sometimes the code changes significantly based on interpreted versions too. Like Python 2.0 and 3.0, the way you do call graphs is completely different. So it's highly language agnostic, but at runtime, because it's looking at the binary, the core of it is kind of common in a language agnostic way. But of course, specific languages like Java, Python, etc., there's some additional work to be done. That's why it's not a green, it's a yellow. So anyway, so to summarize, there's a couple of different approaches to come up with prioritization. And based on our CTO and team's research, runtime was clearly the winner, which is why that's the approach that we at DFactor took. Any questions on this before we jump to a quick demo? Yes.
Accessing internet-based repos, and what do you see from a secure repository and limiting access only to that repository? So you take code in, assess it, store it, and then that repo is where you draw your compile time code.
Is the question about whether it's important to...
Does that mitigate some of what you're talking?
It makes sure that your devs aren't going to the universe like the open Docker Hub, but rather if you have a repo which is locked in and you have some governance on it, so you have some provenance checks on it to make sure that only authorized artifacts go in that. That's always a good thing. Yeah, that can only augment your security posture. So. Yeah.
So when looking at other organizations, how many have you seen have that local repo that they say devs have to use this versus going to Docker and things like that? Do you see a percentage of like 50%, 20%, things like that, or do you have any idea? Just
I'd say, generally speaking, largish organizations do have that. So mid-size SMB definitely no. 2,000 people plus organizations typically is when we start seeing more of it. But of course, every organization is different.
So it is somewhat common on mid-size, larger, but the smaller ones will may just go out to, like you say, go out to Docker and download.
Once, yeah.
Yeah, just use
they
that,
go
that
anywhere.
tool. Yeah, and large ones probably do too,
Yeah.
but some do. But yeah, okay.
Yeah, depends on how security conscious your organization is as well, and the DNA there too. Any other questions before we jump into a quick demo? Yes.
And do you make a distinction between code that's executed? Thank you. Do you make a distinction between code that's executed rarely versus never? You know what I mean? Like once a month, you do your data retention policy or things like that?
Yeah, and that's a great point. The tool cannot make that distinction. I think the human that is using the tool will need to make that distinction. So what the tool can tell you is, did it run or not? Or did it get loaded into memory or not? If you know for a fact there are some components that only get running after a month, just leave the tool on for, by default. The recommendation is just leave the tool on. So whenever that component gets used, the tool will show that it's used. Right. Yeah. Cool. Yeah. I mean, don't think of it like as a one-time scan. I think the mindset it has to be like you just leave it running, and then it'll keep prioritizing over time, continuously, basically.
Quick question, if you're running that all the time, what's the impact on performance of the application itself?
Yeah. I mean, that's a commonly asked question. Pick tools that have less runtime impact. Start with dev test environments. Then go to staging, then go to production. Even in production, don't turn it on in production all the time right away. Start with a canary deployment of your production, then kind of expand it to everywhere in production. And our customers follow that sequence all the time. At DFactor, typically our overhead's low single-digit percentage overhead. So it's in dev test, it's a no-brainer to have it on. In staging as well, depending on the organization. Before going into production, our customers kind of phase out the rollouts. In fact, just another Austin-based company, Open Lending, their VP of cybersecurity was with me. He talked on the stage at B-Sides Austin just a couple months ago. They actually roll it not just in dev test, they actually have DFactor fully deployed in their production environments 24/7 as well. So you have to graduate to it. Cool. Let me show you a quick demo.
If you have any questions online, feel free to unmute yourself and we can ask Wei while he's getting the demo ready. Hopefully the demo gods will be nice to us.
Yeah. All right. Cool. So it's not showing yet.
I have a question before you go in the demo.
Yes.
So you showed this Venn diagram, you have like 6 parameters.
Yeah.
Do you use the value of 6 parameters to compute a score or something for prioritization?
Yeah, we're coming up with a risk score, but right now what we show you is an actual Venn diagram that shows you the overlapping intersections and gives you the prioritization. But we're in the next couple of months we'll actually show a score against it as well. So, yeah. Cool. So here's the DFactor product, and I'm going to go slowly because the hotspot that I'm going after in this room is taking a while to refresh the screen. There it is. Okay. So here's an example of a Venn diagram. This is a CE application that is installed in a container image. So instead of showing, if you just did a container scan in this case, you would just see 124 vulnerabilities. But in the DFactor console, we're showing this is used, and this is where exploits are available. And seeing the intersection of this Venn diagram gives you a powerful piece of information. Here, you have 2 out of the 100 and something that are actually used. They have exploits available, and they're vulnerable. So that obviously needs to be prioritized higher. So that represents the highest layer of risk. The second highest layer of risk for you is these 29, which are used in memory, and they're vulnerable. And then the third conversation that you can have with your developers is, why do you have a bunch of vulnerabilities that are sitting in your container images in this case, which are never used by your application? So you can actually have that conversation of possibly removal of certain packages in the container images, or maybe switching to a different base image depending on what makes sense for you. Any questions on this? Because I think this is when we show this, a lot of the AppSec folks have that aha moment, which is, which truly gives them that, okay, that helps me prioritize based on true risk. Any questions on this?
Should I go first?
Yeah, go ahead.
Okay. So how is the tool determining if something is used?
Yeah.
Couldn't there be kind of a lot of error in that?
No, that's a great question. That's where 4 years of work and 14 patents have been filed in that area. But just to summarize it, the way DFactor assesses usage is, and I'm at this time I'm talking about container images. Container images are installed as packages. Container images are composed of a bunch of packages, right? When an application is running, or when that container is running, dfactor loads a library called libdf.so into the entry point process of the container. That library then trickles over to the other children processes, which essentially is other processes running in that container image. That library examines whether files, network activity, memory activity, etc., what has been exhibited by looking at the various parameters of behavior of that application. Those files are then mapped to the packages that have been used. So when we say libc6 package sitting in your container image is a used package, for example, we're actually looking at the shared object files and executables that belong to libc6. How many of them have been touched by that application over the course of the time when the app was left running? Even if one of the shared objects or executables is marked as used, then dfactor flags that package as a used package, therefore telling you to go fix the vulnerabilities in that package. Answer your question? Yeah.
I guess I can provide you a little example. You know, at a place I was at previously, we had an instance where, and this is an extreme example, where we kind of found out about a year later after we had shipped something that no one was using a screen because we had found out that it never worked. And, you know, so kind of a situation like that, is a tool like that going to pick something like that up where, yeah, we intend for it to be part of the application, but it's maybe, you know, down such a weird path that hardly anyone ever uses it. So could that be an error and, you know, picked up by this tool potentially? Or
yeah, well,
missed?
Technically this, you know, it could pick something like that, but that's not our primary purpose. We're an application security company. So our goal is to prioritize the used and unused based on risk, not as much to determine QA code coverage and things like that. There are other tools for that maybe, but we're not in that specific business. Yeah, but one could kind of sort of use this in that context as well. But yeah, true. Yeah, but we try to stay in our lane. In fact, we partner with a company called Tricentis, which is also a Texas-based company. They're a customer of dfactor as well, for QA code coverage and things like that. So, any questions, I would pass you guys off to Tricentis and their tooling. Yeah.
So additionally, online we have. For us to consider bringing only clean images into current registry, since they are not running it, how to bring only non-vulnerable OSS images and still avoid blocking teams when that is not the case, or reduce SCA noise like several vulnerabilities. So I'm thinking he's asking how to bring images in. Do you all provide sandboxing and things like that, or because you're wanting to, or you're just calling out to the registries as they're using them and stuff like that is what I'm wondering. How do y'all deal with that side?
Sorry, let me see if I can understand the question correctly. For us to be considering bringing only clean images to internal registry, since they're not running yet, how to bring only non-vulnerable OSS images, still avoid blocking teams when that is not the case, or reduce SCA noise. My understanding, at least the way I'm understanding the question, is that you guys aren't yet running these containers. If so, how do you provide this insight? Well, you got to run the containers for dfactor to be able to show you, prioritization. If you're not running it, then we don't see it. Right? But I hope I'm understanding the question correctly.
Tiago, if you want to come off mute now and doing clarifications.
Yes.
I'm sorry.
Thank you. Did you say you insert libraries into executables in order to decide if the code has been running or not running?
Yeah, so there's no build time insertion. It's there's no builds that you need to make. But basically, it depends on how your app is deployed, the way Deepfactor is rolled out. If it's a Kubernetes application, for example, all you do is helm install Deepfactor. It's a webhook. It's a mutating admission controller webhook. And in the override YAML file, you specify which namespaces, which tags, which containers, etc., that you want Deepfactor to watch. And Deepfactor inserts a tiny little library into those containers when the processes are starting up within those containers. So there's no host-based agent or anything like that to be installed. It's a tiny library that resides in the container process itself in user space. That's the area of innovation that we've created, which is essentially taking something like an eBPF, but putting that in a lightweight manner in the user space process itself, because that gives us the opportunity then to observe running containers as well as running non-container monolithic applications. And for containers, because of that running in user space, we're able to watch both managed Kubernetes environments as well as unmanaged Kubernetes environments. Like, for example, if you're using EKS Fargate or ECS or Docker Swarm or Lambda with containers, modes like that, not having an underlying way to observe those running applications is a limitation. With Deepfactor, you don't have that limitation because you can actually simply put that library file in the container image itself. So you have two different options. Either do a webhook install or use our CLI tool called DFCTL to run it if it's a monolithic app, non-containers. If it's a container app that is running in a managed environment, then use just drop the library file in the container image itself. So a few different options to cover majority of the deployment types. The only thing we don't support today is Windows. And I see some claps in the room, but it's to do runtime for Windows is very different from runtime for Linux, which is why we chose it to do Linux right now.
One other quick question on your access level.
Yeah.
One of the big differences in scanners is whether it's an authenticated scan or unauthenticated. Obviously, you get more information from the authenticated. How would you categorize Deepfactor?
Oh, that's from a static scan perspective. We support both cases. Obviously, it's good to make sure that there's some level of authentication for your registries, at least given your business cases, depending on your organization and etc. But Deepfactor supports both.
Because you're not really doing authentication or whatever they're exercising of the application is what y'all are watching and seeing.
Exactly. However, you get to your registry is not something Deepfactor would do anything about. It's just that if you can fetch it, and we may, we just have to support it in such a way that you can get those containers, and Deepfactor doesn't come in the way. But yeah.
To him over there, it's like, what does your QA path show? Does it actually do enough of the all stuff? So yeah, we only got about a few minutes left. So is there any more questions, or is there anything else you want to show in the presentation here before we need to wrap up?
Yeah. Again, so we talked about container images. This is another example of an application called Bank of Anthos, 9 microservices. In this case, it's composed of Java and Python. We do the same for dependencies as well. So in this case, we're showing you that 51 vulnerable components are actually loaded. I think my mouse hover is not showing because of the hotspot Wi-Fi being super slow, but yeah. Okay, there it is. I think but it's on the portal. Oh my God. I think that would be one request from me for next time is the Wi-Fi in this room. Yeah. Yeah. So, sorry guys. So basically, the black portion in the red bar on the Java dependency shows usage, and the things that are not black are vulnerable Java components that are not used. And if you guys want to go the details of it, we show it down to the level of which classes were actually loaded. For example, we not only show that you have log4j, we'll show you whether log4j was actually loaded, and then we'll show you which classes within log4j were actually touched and called by your application giving you, much more higher fidelity and second level drill down if you want to prioritize based on whether that CVE existed in that class or not. So quite a bit of detailed information when you can actually see what's happening in your app. Now let me. Yeah, that's the class, the originating class. Yeah. Yeah, our recommendation is that if the class has a vulnerability, then don't worry about whether there's method A or method B. Just treat that as high risk because there could be lateral movement, there could be other things in memory, etc. So if a class, if you know the CVE belongs to a certain class, then don't worry about method A or method B. Just treat it as a high risk vulnerability.
You support SCA DSS.
So the section on the right that you're seeing is for runtime security. We do so this presentation was focused on runtime correlated software composition analysis. The section on the right was runtime security, which we didn't cover in this topic. But basically what we do is the standard container runtime security things like Aqua, Sysdig, etc. DFactor does that. And then we map which of those runtime findings are actually violating your compliance frameworks and then show those items here. So yeah.
You support reliability.
Cool. One last thing that I wanted to show you is a QR code so you can download the, for that I can switch back to the internet here. Okay, so let's wait again
So
for this
yeah,
to show.
give it a second here. It's sharing. There it goes.
Jackpot. All right, so I'm going to quickly rush through this since we are almost out of time. But what else can runtime do to you? We only talked about the runtime correlation with SCA, but you also have runtime security, like identifying bad behaviors in your applications when your application is doing bad things, or an analysis of your application in dev and test, or scanning your containers as they come up in your Kubernetes environments, in case the containers aren't as part of your CI/CD pipeline. Scan them for SCA and other vulnerabilities as well, so on and so forth. So there's plenty of interesting things that runtime can do for you. If you'd like to learn more, by all means, reach out to us. There's on your tables, there's a QR code as well for the trial, if you want to check out the product trial. Yes, of course. I wouldn't be standing up here and staking my reputation and career on it if you can't trust my product. Yeah. Yeah, but hey, check it out and check what our customers have to say. We have large organizations using it. There's an SCA white paper. That's the last call out, Kyle, and then Mike, over to you. But
all right, it is now almost 1 o'clock. But yeah, if you guys want any information, additional free trial of DFactor online there, or the SCA paper, look at the QR codes. Otherwise, next meeting will be in January, but LastCon, please, if you want to go to LastCon, you can either buy tickets or be a volunteer, and that'll be in the information on, I guess, YouTube or wherever I get that up. Or you can go look at austin.oasp.org and get tickets at lastcon.org. Thank you again, Kiran.
yeah,
We'll see you next month.
Thank you, guys, and we'll be at LastCon as well. I think I'm speaking too, but yeah, come check us out at LastCon. Look forward to seeing you all. Thank you.
All right, thanks again, everybody.